All right, hey guys, so this video is going to go over the review for Unit 2 test, the day 1 review that we did on Wednesday, October 28th. For our test, that's Friday, October 30th. All right, so the first problem asks you to determine if each of the following relations is or is not a function. So remember that in order for a relation to be a function, every x has to be paired with exactly one y. Okay, so in other words, the x's can't repeat. So if we look at table A, we have an x of 4, an x of 5, an x of 4, and an x of 5. So this is our problem. You can't have an x of 4 going to a y of 3 and a y of negative 3. This is not allowed, so this is not a function. Okay. Again, the x's can't repeat. Each x has to be paired with only one y. This x is being paired with two different y's. All right, let's look at B. An x of negative 1, an x of 2, an x of 4, and an x of 6. All of those x's are different. Sure, they all have a y of 4, but that's okay because the x's are the ones that can't repeat. So the y's are allowed to. That's totally fine. So yes, this is a function. Okay, for C, you have to take a look at those x coordinates. So we have a 7, a 5, a 3, and a 7. This is our problem. We can't have a 7 being paired with a 10 and a 7 being paired with a 2. The 7 cannot repeat. Each x has to be paired with just one y, and this 7 is being paired with two different y's. This is not a function for letter C. Okay, let's look at D. To determine if a graph is a function, you have to do the vertical line test. So what that means is you draw a vertical line up and down going through your graph. If it only crosses once, then it's good. It's a function. If it crosses more than once, it fails the vertical line test like this one. The vertical line hits our graph twice, so it is not a function. Okay, let's try a vertical line test here. So the vertical line test may pass here. It only hits once, but you have to check out the whole graph, and if you find one spot where it fails the vertical line test, then it fails. It's not a function. So if you look right here, the vertical line crosses our graph 1, 2, 3 times. So this is definitely not a function. Okay. Vertical line test here. Just hits once, crosses our graph once. No matter where you put a vertical line, it only crosses our graph once, so this one is a function. Hooray! Okay, so vertical line test. If you can find anywhere in the graph where it crosses more than once, it's not a function. Okay, let's look at 2. Graph each linear equation using the slope and y-intercept. Okay, so y equals mx plus b. The m is our slope, the b is our y-intercept. So if we look at this equation here, I'm going to write our formula above it to help me. Y equals mx plus b. So the m is the number in front of the x, so that would be 1/2. Okay, and our y-intercept is the number that's being added after the constant, or sometimes it's subtracted and then it'll be a negative. Since there's no constant that you can see here, that's as if adding 0. So therefore our y-intercept is going to be 0, our b is 0, so it's going to be the point 0, 0 for our y-intercept. The y-intercept always has an x of 0, and then to figure out what the second coordinate is, the y coordinate, it's whatever the b is. So here it's 0, so 0, 0. X is always 0, and then the b is 0. Okay, so the b is 0 here. Okay, so now let's graph it. So we begin at 0, 0. Then our 1/2 tells us that we're going to move, right? Our slope, our m, tells us how to move. We're going to move up 1, right 2, because positive means up and always to the right. We should always have a positive in the denominator. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Okay, we can reverse this by going down 1, left 2, down 1, left 2, down 1, left 2. Connect our dots, our points. And we should have a nice line with some arrows, and we label it y equals 1/2 x. Double check the slope. It's going upward as we go from left to right, so it's a positive slope, and sure enough, our m is a positive number. Okay. Okay, let's try another one. Our slope, y equals mx plus b. So our m and our b, I just circled both of them. So our m is negative 1/2. The negative 1 tells us we're going to go down 1. Positive 2 in the denominator tells us we'll be going right 2. This negative floating in the middle, just have it belong to the numerator. Okay, our y-intercept, our b is 3. So that means it's going to be at the point 0, 3. The x-coordinate is always 0, and then whatever the b is, that's the y-coordinate, the y-intercept. Okay, so we're going to begin at 0, 3. 0, 3 would be right here. Our y-intercept, our b of 3. Then we're going to move down 1, right 2. Down 1, right 2, because our slope is negative 1 over 2. Down 1, right 2. Reverse, I'm going to go back to where I started, 0, 3, and I'm going to go up 1, left 2. Up 1, left 2. Okay, once you have enough, you can connect them. And label it y equals negative 1/2 x plus 3. Since it's negative 1/2, our slope is negative, our line should be going downward as we go from left to right, and sure enough it is. Great way to check it. All right, let's see what we've got next. Number 3. Identify the slope and y-intercept of each line represented as an equation, a graph, a table of values, or 2 points that fall on the line. Okay, so here we have an equation and we have a graph. So in our equation, we use our formula y equals mx plus b to figure out our slope and our y-intercept. Our slope is the m, and our y-intercept is the b. So here, our m is 5/3, which tells us we're going to be going up 5, right 3. Our y-intercept is this positive 2, the b. So the b is positive 2. To write it as a point, it's the point 0, 2. The x is always 0. It's on that y-axis, so the x is always 0, the x-coordinate. Okay, and then we actually don't have to graph this one, so we just need to compare the slope and the y-intercept. All right, so we found them. Now our graph. To find slope on a graph, we do rise over run to find slope. So you have to find 2 points, and well, they look like they identified some points for us, so I'm just going to make them, just those 2. All right, so we'll use those 2. Go from left to right, just like how we read from left to right, and let's see. Whoops. Our rise to get to this point is going to be 1, 2. And our run is going to be 1, 2, 3, 4, 5. Up 2, right 5. So positive 2 over 5. Rise over run. Our y-intercept is right here, where our line crosses the y-axis. So our line is crossing the y-axis at the point 0, negative 1. Our b is negative 1. All right. And then if we had to compare these, just note that, we have a slope of 5/3, a slope of 2/5. So you're going to you could always put those in your calculator, convert them to decimals to see which slope is bigger. 5/3 is going to be the greater slope. And they have different y-intercepts. Okay, let's look at the next one. All right, let's find the slope of this graph. So this line is going downward. So I know it's going to be a negative slope. So let's see. To get from this point to this point, we have to go down and then to the right. So my rise is going to be 1, 2, 3, 4. 1, 2, 3, 4. Yep. And my run is 1, 2, 3, 4. Rise over run. In this case, my rise was negative. I had to go down. So negative 4. And then I always should be running to the right if I make my triangles this way, which I always do at least. My run is 4. Okay, let's simplify this. Negative 4 divided by 4 is negative 1. So our slope is negative 1. Our y-intercept, where our line crosses the y-axis. Right here is where our line crosses the y-axis. That would be the origin. So 0, 0. Okay, and remember I said my line is going downward, so my slope should be negative, and sure enough it is. Okay, great. Let's look at this one. All right, so this one you should have memorized, that when it's a horizontal line like that, straight across, that is a slope of 0. Now, if you weren't sure, you could do the rise over run. And you'll see that to get from, let's say, this point to this point, you don't rise at all. And then maybe you run over 1. 0 divided by 1 is still 0. But you could just memorize that a horizontal line is a slope of 0. That'd be great. All right, the y-intercept would be right here. Our horizontal line is crossing the y-axis at 2. So that would be the point 0, 2. All right, our table. So for our table to find the slope, we want to do change in y over change in x. That's another way to find slope, just like rise over run, the change in the y over the change in the x. So to find the change in y, we need to see how do I get from 2 to 8? Well, 2 plus 6 is 8. 8 plus 6 is 14. 14 plus 6 is 20. My change in x, 0 plus 1 is 1. We're just adding 1 each time. If you were not sure of that, you could take 20 and subtract 14 and you'd get 6. In any way you part of the table, you would just do 3 minus 2 and you'd get the change in 1. To find change in, you would just subtract the one below, the one at the bottom, the second one minus the first one. The one after it minus the one before it. Okay, so our change in y is 6. Our change in x is 1. 6 over 1 simplifies to just 6. Okay, our y-intercept, the y-intercept is whenever x is 0, whatever that y is, that's the y-intercept. So you basically just have to look through the table for when x is 0. So it's the point 0, 2. Okay, our y-intercept always has an x value of 0. Okay, 2 points. So when you're given 2 points, you can use the formula or you can make a table. So I'll do both just to remind you, see which one you like better. In our table, we just list the points. So 0, 8, 7, 11, all right, x, y, x, y. So x, y, x, y. Change in y over change in x. To get from 8 to 11, 8 plus what equals 11? If you can't figure that out, just go backwards and subtract. 11 minus 8, you're going to figure out that it is 3. 8 plus 3 is 11. To get from 0 to 7, I have to add 7. Wasn't sure, so 7 minus 0, and you get 7. So our change in y is 3. Our change in x is 7. So our slope is 3 over 7. And that's already simplified. Okay, if you would prefer to use the formula, here it is. y2 minus y1 over x2 minus x1. So let me just label these x, y, x, y. So it's kind of just like the first x, the first y, the second x, the second y. I say like x number 1, y number 1, x number 2, y number 2. So let's subtract y number 2 minus y number 1 over x number 2 minus x number 1. Back to front, back to front. 11 minus 8 is 3. 7 minus 0 is 7. You still get 3 sevenths. You're doing the same thing. You're subtracting the 1 in the back minus the 1 in the front. That's what we're doing in the table too. So whichever way works better for you, it's totally fine. Okay, and the y-intercept, remember, that is whenever the x is 0. So if you look at these 2 points, here is when the x is 0. So this is the y-intercept. The point 0.8 will be on the y-axis. Alrighty. So that is it for our review from Wednesday. Hopefully that helps you guys. Happy studying. Bye.